Okay, so on Tuesday, I just asked you to do a little bit more practice with axes of symmetry, and you had questions 3 and 4 to do. So for question 3, they'd drawn in the axis of symmetry and one side of the shape, and you needed to copy the other side of the shape. So complete these shapes using the axis of symmetry. And what I said on Monday and on Tuesday was that our axis of symmetry acts like a mirror. So I'm trying to draw the mirror image of this shape. So this is 4 boxes over on this side, which means I need to find 4 boxes over on the other side, and then just join the dots together to create the mirror image of this kind of kite looking shape. Okay, so that's all we have to do. You can shade it in if you want, but that's all we needed to do there. Same thing for part B. So you're looking at each of the points that are not on the axis of symmetry, and you're doing their mirror image. So we know that things behind the mirror are the same distance behind the mirror as they are in front of it. So if this is 1 box this side, it must be 1 box this side. And if this is 4 boxes on the object side, it must be 4 boxes on the image side. And then I just use my ruler to join those points together. So here we go. And you can see we've made an exact mirror image for around our axis of symmetry. This one, 2 boxes over. So 2 boxes behind the mirror, 4 boxes over, so 4 boxes behind the mirror, and then we're just joining the dots together. Okay, so if you found this a bit confusing or weren't sure what you were being asked to do, hopefully this makes sense to you now. We have our mirror shape. And finally, this one here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's where my mirror image is. These guys are on the axis of symmetry, so I don't need to do a mirror image of them. 1, 2, 1, 2. And then I'm just joining the dots together. It's like I'm making the other side of a butterfly. This is kind of like a robot butterfly, what do you think? With its spiky wings. And there we go. And you don't need to shade it in, but you can if you want, if you think it looks a bit better. Excuse me. Okay, so there are 2 more parts to this question. It might look like it's getting a bit more complicated, but it's really just the same thing. 4 boxes in front of the mirror, 4 boxes behind. Same thing here. 2 boxes in front, 2 boxes behind. Same thing here. And it is best to use our ruler to join the dots. But if you were getting a bit stuck for time, I wouldn't penalize you if you just did this by hand without the ruler. Especially for these bits here. We could do that without the mirror without the ruler. There we go. Perfect mirror image. Now with the star. So again, you don't have to measure the distance, just count the boxes. 3 boxes on one side means 3 boxes on the other side. That's on the line. 2 boxes, 2 boxes, 1 box, and another 3. And there we go. So I can complete my star. And it should be perfect mirror image of the one that we started with. I need to get a shorter ruler for fitting on this desk. The last part here. And there's my completed star. Okay, so that was just to help us really understand how the axes of symmetry work. Now, you also had question 4. They gave us a shape and they said, how many axes of symmetry do these have? So you already did this by drawing in the axes of symmetry on Monday, but we remember our square has 1, 2, 3, 4 axes of symmetry. Our rectangle, though, only has 2 because we can't go through the diagonal. Remember, if we try to fold along the diagonal, the edges don't line up. We don't get a mirror image. A rhombus. So we have 1, 2. Remember, they're parallel to the sides. And a rhombus is like a squished square. So we have those extra 2 axes of symmetry as well. 4 axes of symmetry for the rhombus. An isosceles triangle just has the 1, dividing it into 2 equal right-angled triangles. But our equilateral triangle can be divided in all 3 directions. And our scalene triangle has none. Now, I hope you saw part B here. Draw a shape which has an infinite number of axes of symmetry. Okay, if you didn't do this last night, if you didn't spot this, then pause the video and think for a second. What's the only shape that no matter what lines I folded along, I'm always going to have a mirror image? And that I can draw an infinite number of lines of symmetry. What shape could I do this with? You can actually even see it forming while I do this. It looks like a star, but a star doesn't have an infinite number. If I keep going and I fill in all the gaps here, it's not a star. A star isn't the shape that's formed, it's a circle. I didn't do that with my compass. So a circle is the only shape that has an infinite number of lines of symmetry. Because no matter what direction we turn it, it always looks exactly the same. Okay, thank you.